Hello and welcome. This is Columbia Basin Research's fifth video in a multi-part series on using Program User, which stands for User Specified Estimation Routine. User is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. Today, we'll be looking at how to estimate abundance. We are looking at a situation where we are interested in estimating the total abundance of a population. We must take into account individuals never observed. In video number 3, we had a defined formula for population based on what was seen. Here in this fourth video, we don't know, so we must estimate the unseen animals. This example uses a constant effort removal technique, where the population of interest is a pest species and it is advantageous to decimate the population. A constant effort P is used at each sampling occasion. Let n represent the total number of individuals at the beginning of the study. For the initial sampling event, the number of individuals removed will be NP, number of individuals times the sampling probability. For the second event, the number of individuals still remaining is N times 1 minus P, so the expected number of animals removed will be N times 1 minus P times P. For a study with 4 removal events, we can define the categories and probabilities of occurrence as follows. As an example, N3 represents the number of animals that were not caught in the first and second periods that were then caught in the third period. But this table is incomplete. Remember that the categories for a likelihood must be mutually exclusive and exhaustive, and if we haven't taken into account the animals never captured, the complete table is as follows. Let's fire up Program User. In User, define the parameters as I'm doing here. Click Next. In order to make the likelihood definition cleaner, we will define the convenience function Q equals 1 minus P. Click Next. For the likelihood definition, enter the first 4 categories as I've done here. The final 5th category will represent individuals never observed, an unobserved category. We have no counts to enter for this category. In order to indicate that this is an unobserved category, in the label column, enter the abundance parameter in parentheses and press Tab to move to the probability column. You will notice that User puts the text n dash dot 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 in the counts column to indicate that the counts are assumed to be n minus the sum of all the other categories in this likelihood. User also italicizes the text to distinguish it from the observed categories. Enter the probability as you would for any other category. You can then enter your counts directly as I've done here. If you prefer to keep your category counts and model definitions separate, using a text editor, create a category count file as I've done here. Load that file into User using the Load Category Counts action under the File menu. If everything was done correctly, your new count should appear, and when you click over to verify the model should be valid. Click Next. At the parameter seeds content page, it is clear that the seed for the parameter n needs to be changed to be at least as large as the sum of the counts. For this type of model, it may take several attempts to find a seed which will allow the optimizer to converge to find the parameter estimates. In this example, enter 20,000 as the seed for n. This should lead to the successful estimation of the model parameters. In the optimizer content page, Fletch is the recommended optimizer for this operation, but you may change iterations, precision, and proportional step size to achieve desired results. These changes should be subtle, up or down a decimal place. Once an optimized parameter set is found that seems reasonable, precision and step size can be set to smaller values to improve it. Now click on Estimate the Model Parameters and hit the Estimate button. We can now look at the model diagnostics to see how well the model fits the data. If you click on Parameter Estimates, you can see the abundance estimations. Our model estimated that there were 13,110 animals and that the capture rate was 0.771836, or about 77%. Proceed to the Observed versus Expected plot under View Model Diagnostics. Note that this plot, as with all plots in User, could be made larger simply by enlarging the User dialog window or by using the zoom slider at the top here. If you go to the Residuals Plot content page, you'll observe that 2 of the observations fall well outside the plus minus 1.96 range. If the data fit the model well, the residuals will follow a standard normal distribution, and 95% of the observations should fall within the plus minus 1.96 range. Perhaps in this case, the assumption of constant effort removal was violated, meaning that this was not the correct model to use. This has been Lesson 5 on using Program User, in which he covered abundance estimation examples. In the next video, we'll cover hypothesis testing. We hope that this video helps you get the most out of Program User. Again, if you have any questions or comments in regard to Program User, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck with your estimation routines, and thank you.